Hello everyone, so in this video I'll show you how to calculate the max pain for options using Alpaca's Python API. So as many of you are familiar, a lot of times you get this weird behavior, usually on Fridays, because that's when options usually expire. So you have like a stock, like let's say Rivian, so excited, it had some good news, it's up quite a bit. But then you get this random like unnatural manipulative looking behavior that just shoots down, and then it kind of like bounces around the rest of the day between a few strike prices. Okay? Or another example, although in AMD it's kind of a daily example, it's like up pre-market and then it kind of a minute before market starts, it kind of shoots down and then zigzags right here. In the case of Tesla, the worst trading day of my life, wiped out an account because of this. Pre-market, it was, and I wanted to close it, but I couldn't because I was driving. But whatever. So that's why you should do everything algorithmically. So pre-market, it was up quite a bit. Market open, just a complete crash down, and then it went like this the rest of the day. Account wiped out. Following Monday, of course, it went back up above where it was here. I think it's manipulation. ChatGPT disagrees. But anyways, the idea, one of the reasons people give for this behavior is the idea that options expire, and market makers and option sellers try to make as much money as possible, like to head. So they hedge their position. They buy and sell the underlying so many times, and it kind of like makes the stock prices go crazy. Sometimes they pin between two different strikes. So like the idea is max pain. So what is max pain? Max pain is defined as basically the strike price in which option sellers make the most money and option buyers get inflicted the most amount of pain, meaning lose the most. Okay. Of course, option sellers can also be little guys, and sometimes option sellers use max pain as a way to choose their strike price. So they'll sell an option with those particular strike prices for cash secured puts or covered calls. But anyways, I'll just show you how to calculate this. Let's be a little bit more precise with the definition. And the notation is really annoying because uh, the strike price and the stock price at that strike price makes it confusing. So let's abuse a little bit of notation and let's say this. Let's say S underscore capital K will denote the stock price when it equals K, meaning at expiration it equals capital K. And then I'll have the open interest of put options with strike price little k with this notation. Open interest of call options with strike price little k is the open interest of call. And just to remind you, open interest is number of contracts still outstanding and haven't been closed yet. And that is used as the amount of contracts. Okay. So an open interest is only defined like at the end of the trading day, so you can't get it intraday. But anyways, so let's define the pain from the. We're gonna actually define it from the option buyer's perspective, but in terms of like how much the option buyer is gonna lose, right? So the pain is how much they're gonna lose. So with this notation, it's the pain when the stock price is at strike price. Stock price equals capital K, which is one of the strike prices that's available. So what is the pain? The call buyers paid a ton of premium. It's just the constant. So that's why I wrote it like this. And what are they gonna make, right? So they're gonna make, in the case of put options, if the strike price is little k, they're gonna make k minus s big K, or zero. If the stock goes up, they're just gonna make zero. It's a put option. You're bounded by you can't lose money other than the premium. For call options, you make the stock price minus the strike, right? So because this is what's confusing is the stock price here is big K, so it's big K minus K. Okay, and then the open interest for calls with strike little k is here. Okay, so what you get when what you get here is you get like a pain for strike price capital K, and we want to maximize this pain. And that's the goal of this video. So I'm going to assume that you guys watched my previous video on options trading with Alpaca's API. So you go to my YouTube channel, you get options trading with Alpaca. And if you look at playlists, I also have the Alpaca Markets playlist with a lot of videos. And by the way, like and subscribe. I'll have like a weekly video on this type of stuff. So please like and subscribe anyway, because YouTube hates me. So let's get started. I'm assuming that you watched the previous video on Alpaca's options, but I'll try to make it as comprehensive as possible. So the first thing we need to do is install the Alpaca Python SDK. So pip install alpaca-py. And then, like in my other videos, I have this utility function that basically displays things as a data frame. So like there's more detail in other videos, but basically like a lot of the responses are a list of dict-like things that I like to display as a data frame. Next thing we'll need to do is we're gonna need to like load our Alpaca API key and secret. If you're using collab, you can usually store it in these secrets things. So you can do from google.collab import user data, and then you can do Alpaca API key equals and then Alpaca API secret equals user data get Alpaca API secret user data get Alpaca API key. And then we have to define our trading client, Alpaca. Okay, so the trading client will do from Alpaca, that client, import trading client equals Alpaca API key, Alpaca API secret. And if we're using a paper account, paper is true. And now to get options for a specific date or the option chain, we're going to use the get option chain function that I showed you how to do in the options tutorial video. So basically this function takes an underlying symbol or either an expiration date or a list of a range of expiration date, like expiration date greater than or equal to this or less than or equal to that, a strike price greater than or equal to this, less than or equal to that, and a contract type could be call or put. But I don't want to get into details because I spoke about that in another video. But you can do something like this. You can do df options chain equals get options chain symbol expiry. And then if you look at the options chain, you get this type of thing where you get like the contract type. So you see the name is like February 21st, $50, what did I using is this? I'm using Tesla. Symbol is Rivian, sorry. How did Tesla come in? I ran something before. So Rivian, $5 call, $6 call, etc. But what's important here is type is going to be call or put. That's going to be important for us. Strike price is important for us, and open interest because that's what we're going to use for like the amount of contracts. So those are the important things. And notice that the expiration date is supposed to be all the same. If you see here, you see it's all February 21st. So now that's the option chain. So now remember, to calculate the max pain, we want to do it in terms of like how much the option buyer is going to lose. All the option buyers combined. So it's premium minus the sum of all they're going to make together, which is open interest times payout for each contract. Okay, so premium of course is a constant. It's just some big number. So let's get rid of that for a second. So we're gonna basically go through each pane and find the max pain. First we'll need all strikes because we're gonna iterate through all strikes. So I'll write all strikes equals df options chain strike price dot unique, and then I get all strikes. And note this is a float, which is good, all of the same type, because later on you'll see that open interest isn't that. So we have to iterate through all strikes, and what do? Let's save a dict called pain, and we'll calculate this. We'll exclude the premium because it's a constant with the data we have. So for strike and all strikes, first thing we need to do is we need to split into call and put. So I'll do df put equals df options chain, df options chain dot type equals put, and then the other one is similar, df options chain dot type is call. So now let's do this thing. We'll do pane at let's use the same notation. So I'll do sk stock when the stock price is at that strike, because to differentiate from like the strike of the contract itself. So I'll do pane sk equals, what do we need? So we need, first of all, we have the big minus sign, so we'll do big minus sign, and then what we're gonna do is we're going to for each term is going to be like this. So for puts, it's going to be df put, and with open interest for puts, just so you see for a second, for puts, if I do df put open interest, you'll see that it's sometimes none, and it's as type, it's .d type, it's an object, and it's not a float. So you're gonna have to convert it to float. So we can do that by doing open interest dot as type float, and if it's none, that just means that there's zero open interest. So this is the put open interest, and for each one, we calculate the max for the put. It's the strike minus the stock price, or zero. So I'll do df put that strike, doesn't need as type float, minus sk, or zero, and I'll do np dot maximum. Let's just make it a little bit more clear. So I'll do this like I'll call this put pane is negative that, and you could also do without the negative and just maximize this, but I want to do it in terms of a max pane. That's why I did it this ugly way. So I do call pane, the same thing, except now this is for call, it's sk minus df call strike price, or zero, because it's a call. Great. So now so this is with the sum over all these guys, and here we sum over all these guys, and I did this, and I guess I don't have numpy, or import numpy as np. So now I should have, I probably did something wrong. Does this work? So I have the call pane and put pane. So I'll do pane at sk. I probably did something wrong. Equals put pane plus call pane. Put pane. I knew I did something wrong. Put pane is not defined. Why is it not defined? Oh, equals minus. So now I add them together, I get this pane. So let's see how this pane looks like. It looks like this. So you see, and now I have to find the maximum of this pane. So I like using pandas. So pd.series. I'll do it the less efficient name, because you could do like, let's say you could do n largest, I don't know. Does this work? It's not a good idea. Let's just do it the less efficient way. Sort values ascending equals false. So now I sort them by ascending values, and the maximum pane is the one. Something went wrong. I did df put open interest here. Sorry. So call open interest and call. Okay. So now you see the max pane is more reasonable, because it's premium minus this. That's the amount the buyers lose, because they paid a premium, but it's a constant, so that's why it's negative still. So if I put this here, but if we want to take the top guy, it'll be dot index 0. So this will be the max pane. So like we can wrap this into a function. We can do def get max pain. And by the way, this is Rivian, and if you look at max pain for Rivian, you can Google Riv max pain, and Rivian max pain is Rivian max pain is 13.5, so that seems about right. Okay, so Rivian max pain is right. And now, sorry, I don't know how you guys saw my email. That's bad. Okay, so now we can also write. Let's wrap. Sorry, I got flustered because it showed my email for a second. We can write this as a cleaner way. So I can write def get max pain symbol and then expiry, and then what we can do is we can do df options chain equals. So we got Rivian right, but let's make it more general. Df option chain equals get options chain, and what did we have here? Remember, we had underlying symbol was symbol, and then we had expiry. That's good enough. And then let's put the rest of the stuff here. We can do all strikes is this. Oops. All strikes is here. And then let's iterate through these guys. We're gonna do pain is this. Sorry, it's getting a little ugly. So basically I'm just repeating what we did above, and then we're gonna return this value, which is the max pain. So let's just try it for a few more things and to make sure we got it right. So if I do get max pain, we said Rivian was 13.5. Let's see if that works. Okay, so now if I do, let's try our trusty buddies at Tesla, 347.5, and let's try AMD, just to see that we got this right. So we got AMD max pain is 114. So if I do, let's say Tesla, you see if you go to max pain, you see 347.5. Okay. And now if we go to, and this is just option charts version, and if I go to AMD, you see it's 1 to 14. So we got that right. So anyways, I hope you guys learned something. Please like and subscribe. It helps YouTube hate me less because sometimes I get no views. So thank you guys so much, and see you in the next video. Peace.